Today is the 17th of May 2024, and this will be our third video on probability, the revised one, okay, the one that we are adding a bit more, okay. So I've taken you to the first one, which is what the mutually exclusive one, which we did at length in the series we did earlier. And then yesterday I showed you this time around you are not picking one, you are picking two at the same time. So for instance, if you throw a coin, you either get a head or tail, okay? But if you throw two coins at the same time and you want to get two tails or two heads, okay, the probability reduces. If you throw a die, like a dice, okay, and you want to two dice and you want to get two ones or two twos or two threes, the probability reduces, because if you throw one and you want the probability of getting a 6, it's 1/6. But if you have two and you throw it at the same time and you want to get two threes showing on both dice, then you're going to get 1/6 times 1/6, which would be 1/36. So I brought some examples, a box where you have to pick two red dresses or three green dresses, two green dresses, okay. And then, yeah, so that was also, I showed you how to use the AND law yesterday, okay. So now today I'm showing you another aspect. So that's our recap, okay. I'm showing you another aspect. So watch last video for recap. Actually, I recommended two probability videos. It will help you a lot. Thank you everyone, to all my subscribers. Okay, I appreciate it a lot. Okay, please, if you've not considered subscribing, I don't really know what you're waiting for. Okay, those of you who have subscribed, please like, share when you get the new videos, follow on other platforms, help us circulate the platform, okay. And new subscribers are welcome, okay. If the account is not yours, you can subscribe your own, you can create your own account or ask somebody to help you create your own account, okay. If you want to use somebody else's account to subscribe, ask permission. It's the right thing to do. In the comment section, you normally see please follow my notes/script. These are my notes, okay. So follow the note as I go through with you. If there's anything in it, I would correct it, okay. But at times, saying like mental math, root of that, root of this, root of, is a lot of mouthful. So you end up hearing root 3 or 3, or instead of root 9 times root 9, you hear root 9, root 9. It's the same thing, please. So please follow my notes/script. Don't be confused. And if you can't hear me, um, you will get used to me in a short while, okay? And follow the note as well because you can't go wrong. Math is like giving a direction: 10 left, 10 right, 10 left, 10 right. It depends on your thinking pattern, okay? Somebody can be going up the road and you tell the person when you get to the junction, 10 left, 10 right, and then 10 right again, and then you are wherever you want. Okay, somebody can also be going to the same place. You will say 10 left, 10 left, and then go straight ahead. Okay, that is math. So at times, if you decide to copy somebody, they might end up getting to the wrong answer or wrong destination, and then it's your fault. Okay, so it's good to understand it yourself and then use what you've learned to help you navigate because if you set the equation right, everything else is calculation, and that is where you can just apply what you've learned to get to your answer. Okay, and if you do it well, you should get your answer. Okay, I hope I'm clear on that. Please beware of scammers, these people. Okay, beware of them. Take care of yourself online. Okay, I don't need to say more. If they're asking you for donation, I haven't asked you for donation. So if you give them your money, then it's your fault. Okay, you know how I sound by now. Okay, so if you donate and you think you're doing it's coming to this platform, it's really not. Okay, thank you very much. Recap. Watch last video for recap, please. Okay, I've said a lot about that in the beginning. So far, we've looked at independent, dependent, independent, and mutually exclusive events. Okay, um, mutually exclusive events will not happen at the same time. Okay, independent is uh you are picking two items, okay, and you might not end up getting those two you want, but if and because of that, um the chances of getting the two exact item you want without looking is reduced. Okay, and that is where the end law come in. We'll be looking at how we combine the or and the end law. Okay, very soon. Let's go to our status, and it says using multiplication so that we can think a bit faster. Since we are getting into the exam mode, we want to learn how to think faster, not just in math but in other things, okay, in other subjects as well. So we are simplifying the root of 45. Okay, root of 45 can be written as root of 9 times 5, because 9 times 5 is 45. If we do 15 times 5 times 3, we can find the square root of any. So we'll end up coming back to root of 45. But 9 times 5, root of 9 is 3. So our answer becomes 3 root 5. Okay. I hope by now you are getting the gist, because we are simplifying. Now, root of 27, sorry. So we will apply root of 9 times root 3. Root of 9 becomes 3. So the answer will be 3 root 3. Yeah, so that is a simplified form. Root of 32. So we'll use 8 times 4. Okay, so root of, or we can do 16 times 2. Okay, so root of 4 here is 2. Root of 8 will be another 8 times 4, which will give us 2 times 2, which is root 4 times root 2. 2 times 2 is 4 root 2. So that will be our answer here. Root of 75. Okay. So 25 times 3 is 75. So root of 75 can be written as root of 25 times root of 3. Root of 25 is 5. So our answer will be 5 root 3. Root of 50. Okay, so it's another root of 25 times 2. Okay, root of 25 is 5. So our answer will be 5 root 2. Root of 63. 9, 7 is 63. So we can have it as root of 9 times root of 7. Okay, root of 9 is 3. So we have 3 root 7. Root of 24. Okay, so these are really, if you know your timetable, you cannot go wrong. Okay, root of 24. Okay, so it's 8 times 3. So we have root of 8 times 3. So now here, root of 8 can be written as 2 times 4 times 3. Okay, now root 4 is 2. So we have root 2 root 6. So that's what I have for you today. So let's look at the probability part 3, our revision probability part 3. Okay, so I said here we've looked at the OR law, which I've told you, and the AND law. Today we'll look at dependent events. Okay, now Simon has 10 colored wrapper chocolate in the box. You know, normally when Christmas is approaching, celebrations and all those sweets, they make them in colors. They make them colorful. Okay. So now in Simon's box, 3 sweets are red. Okay, and then 7 sweets are blue. Okay, with maybe different flavors, but they are all sweet chocolates or chocolate sweets. So the probability of picking a red is 3 out of 10 because there are a total of 10 in the bag or in the box. The probability of picking a blue is 7 out of 10. Okay. One sweet is removed at random. That was what Simon did. Okay. And noted, but it's not replaced. So Simon dips his hand in the box or in the bag, bring one out, maybe consumes it and doesn't replace it back. Or maybe put it on the side. So now you have 9 in the box. Another sweet again, okay, is removed at random. Okay, so you have 10, one is removed, not replaced, so you have 9. And then another one is removed, no replaced, so you have 8. So it can be like Simon. Maybe he's at that age that he takes a chocolate, one chocolate in the night. Okay, some people do that. After dinner, they want one chocolate. So they always have a box of chocolate somewhere. So maybe this is what Simon did. We don't know. Or maybe he gave one out. He didn't replace them, gave another one out. Okay. Now find the probability of picking a red followed by a blue. Okay. Now the probability of picking red is 3 over 10. Okay, before, because he started with 10 sweets. Now to pick a blue, now he has 7 sweets and a total of 9. Okay, so here now, if you want to multiply the numerator and the denominator, it will be 21 out of 90. But you can simplify. Okay, so 3, 1, 3 goes into 9 3 times. So you can have 7 out of 30. So that will be the probability of Simon picking the first red sweet, not replacing, and the second blue sweet, and not replacing. So after picking the second, he will have a third 8 sweets. So if he's going back to pick a red sweet, then you have 2 out of 8. I hope you get the point I'm making here. Okay. It's not part of the note, but I wanted to stress that. Okay. These are called dependent events. So even though you are looking at the end law, they are not being replaced. Unlike when we saw the two dice, you can't cut out the ones from the dice. They are still there. So if you want 2 ones and you throw the die, it's 1 out of 36. The 1 cannot be removed. So if you throw it again and you want 2 1, it's 1 out of 36. Okay, but here it's chocolates or sweets. He's taking 1. He didn't replace it. He noted the color. So now he has 2 red, and then he has a total of 9 sweets in the bag. Then if he goes back again and pick a blue, there are 7 blues. So now he has the probability to be 2 out of 7. Assuming he did pick a blue and he noted that, then now instead of a total of 7 blue sweets, he has a total of 6. So that will be dependent on what he wants to do next. Okay. So that's why they're dependent probability. You still use the end law here, but because they are not being replaced, unlike in the dice session, you can throw 2 dice and you want 2 ones, and actually you can cut out the ones out of the die. Okay, even if you throw it again, you still have 6 dice. You still have 1 2 3 4 5 6. Okay, that is the difference here. So if you want 2 red sweets, okay, if Simon wants 2 red sweets, the first one will be 3 out of 10. Okay, and the second one, there'll be 2 red sweets left. So 2 out of a total of 9, because he didn't put them back in the box. Okay. Here again, you can have 6 out of 90, or we can reduce them. How many 3s are in 9? 3. How many 2s are in 10? 5. So you have 1 out of 15. So you see, these ones, the chances of it happening is very, very, very slim. That's why your probability here is very low. Okay. Now, two blue sweets. Now, there are seven blue sweets here. Okay. So he picked the first one. Okay. The first one has been paid. So, which is 7 out of 10. Okay. And then, now there are six blues. Okay. So, he goes back again. Six and then a total of 9. So 6 out of 9, which you can also reduce here. How many six? How many threes do you have in 6? 2. How many threes do you have in 9? 3. Okay. How many twos do you have in 10s? 5. So you have 7 out of 15. So that will be your probability. Okay. Okay, another one, the first blue, second red. So here again, you are going to use the time. So it's blue and red. Okay, you can't say blue or red. He wants a first one to be blue and the second one to be red, and he's not replacing them. So he picks blue. Okay, he picks it, look at it, noted it. Okay, so he is aware that it's taking one of the blues, and he's aware that he only have 9 sweets in his box. Okay, so the probability that will come next will depend on what he wants, and the second round he wants a red. So to get a first blue is 7 out of 10, and the second red will be 3 out of 9. Okay, so he still has the 3 red sweets or chocolate sweets, and now he's have a total of 9, because again he didn't replace it. How many threes do you have in 3? 1. Threes in 9, 3. So you have 7 out of 30. So that will be your probability. Now, Jess has 9 colored Skittles. Okay, children like Skittles a lot in her box. Okay, she removes one at random and does not replace it. Okay, so 2 red, 3 blue, 4 black. So it has a total of 9. She just chose the second one. Okay, find the probability of a red followed by a blue. So this is the same argument, no replacement. So to get a red and second time a blue, you have 2 red over a total of 9. That is what he's actually just started with. Okay, now she has 3 blues, but now a total of 8. Okay, so now it will be 3 out of 8. So here again we can cancel out. How many threes do we have in 3? 1. How many threes do we have in 9? 3. How many twos do we have in 2? 1. Twos in 8? 4. So the numerator becomes 1. The denominator becomes 3 times 4, which is 12. Okay. Follow my notes, please. So it's 1 out of 12. Now, two reds. What's the probability of guests having two reds? So, first pick red, no replacement, and second pick red. Okay. So we are using the end law again, but this time it's dependent on what happened the first time. These are called dependent events. Okay. So now the first one, you have a total of two red, so 2 out of 9 times, now you are left with 8. You have only one left, 1 out of 8. So how many twos do we have in 2? 1. How many twos do we have in 8? 4. So our probability here will be 1 out of 36. Now, two blacks. Okay, so first pick black, second pick black, a total of 9, and we have 4 black skittles. Okay, so the first pick, 4 out of 9, because that is what that we start with. Okay, then the black wasn't replaced, so now we have 8. Then we have 3 blacks now, so the second pick will be 3 out of 8. But because it's black first and a black second, we multiply, we don't add. Okay, we can write 12 divided by 72. Okay, or we can reduce it to the simplest form. How many 4s do we have in 4-1? How many 4s do we have in 8-2? How many 3s do we have in 3-1? How many 3s do we have in 9-3? So we have a total of 1/6. Okay. So I hope you're understanding our dependent argument here. Okay. Now let's look at one more. Just again, blue followed by red. So here, blue and a red. Okay. So we have a total of 9, and then there are 3 blue sweets. So that will be the first probability. And a red. Okay. Now we have a total of 2 red. But because it's not replaced, we only have 8 now, because it's been reduced by 1 just by picking the blue sweets. Okay, so we can have 6 out of 72, but we can still reduce. How many 3s do we have in 3-1? How many 3 do we have in 9-3? Okay, how many 2s do we have in 2-1? How many 2s do we have in 8-4? So we have 1 out of 12. Okay, now I have a small here. These are dependent events. Okay, because it depends on what you picked, you didn't replace it, and it depends on what is in the box. So if you pick a color, the color reduces and the total in the box also reduces. So the second time you go back, you take all this into consideration, which affects the probability you work out. But here, you still use the end law, which is times. Okay, so these are independent events, not replaceable. The second event depends on the first. Okay, so this is what I came to share with you. So please, if you are doing a higher paper or a foundation paper and you can keep up with this, now I've shown you mutually exclusive events. I showed you dependent events like throwing a two die, and here you can replace it because if you want one and one, when you throw it, the one is still there staring in your face. Okay, so if you want another one in one, you is still one out of 36. Okay, but here you have a box of sweets. You pick one, so you don't replace, and then you go back and pick another one. Okay. Thank you. Please subscribe, like, share, follow. Create your own account if you don't have one. Please follow my notes/script in case I miss something out, okay? And if I'm going through and I miss something out, I'll leave it in the comment section, please. So be looking at the comment section also. And then beware of scammers, okay? We are not soliciting for funds here. Thank you to everyone who has watched who is watching the video with me today, and I'll see you in the next.